Welcome to this class about composite design pattern. I will go through the theoretical aspect of the pattern, but we will also code the pattern together in C#. Let's get started. The intention. The composite pattern organizes objects into tree structures to represent part-whole relationships. It enables clients to treat individual objects and groups of objects in a consistent manner. A classic use case of the composite design pattern is a file system. In a file system you can have files and directories. So a directory can contain both files and other directories. And this creates a tree structure where directories can be nested within other directories. And the key benefit of the composite pattern here is that files and directories can be treated uniformly. For example, you can call the same method like display or getSize on both a file and a directory, and each will behave appropriately. The participants, what entities are part of the pattern? So we have the component. The component defines a common interface for all objects in the composition, provides default behavior when appropriate, and includes methods for managing child components. Then there is the leaf. A leaf represents primitive objects in the composition with no children and defines their specific behavior. The composite. A composite represents objects that have children, manage these child components, and implements child-related operations defined in the component interface. And then we of course have the client, and it interacts with objects in the composition using the component interface. The consequences. What happens when I implement the composite pattern? It defines class hierarchies consisting of primitive objects and composite objects. Primitive objects can be combined to form more complex structures, which can themselves be composed recursively. Wherever a client expects a primitive object, a composite object can be used interchangeably. So in short, primitive objects can be nested recursively and composites can replace primitives wherever needed. It makes clients simple. Clients can interact with both individual objects and composite structures in a consistent way, typically without needing to know whether they are working with a leaf or a composite component. In short, the client can work with leaves and composites in a simple manner. It makes it easier to add new kinds of components. New composite or leaf subclasses integrate seamlessly with existing structures and client code, eliminating the need for any changes on the client side. In short, adding new kinds of components doesn't require much change. A downside is it can make your design overly general. While the composite pattern simplifies adding new components, it makes it more difficult to enforce restrictions on what the composite can contain. In cases where only specific components should be allowed, the type system cannot enforce these constraints. In short, enforcing restrictions on a composite can be difficult. Now let's have a look at the diagram. What does the composite pattern look like in UML? So we have the component, which would be an interface or abstract class. It defines methods for adding and removing components and has an operation. The operation could be displaying information about the components, for example. The leaf and composite inherit from component. Let's start with the composite. As you can see, the composite implements every method from the component. Typically, it has a collection to which components can be added and removed. Components meaning both leaves and composites. And the leaf only inherits the operation. This is because it is the final node and it should not have a collection of composites and leaves. Now for the assignment. The assignment is implement the composite pattern to model a file system where directories can contain files and other directories. You are tasked with creating a simplified file system that allows you to manage both files and directories. Both files and directories should be treated uniformly, meaning they should inherit from a common interface. The first task, the common interface. Create a common interface or abstract class for both file and directory. And the first requirement is the class should have a method for displaying information. The second requirement is the class should have a method for adding a file or directory. And the third requirement is the class should have a method for removing a file or directory. Let's start by creating the file system component. It can be either an abstract class or an interface. I will make it an abstract class. If you're using an interface, that is fine. You can keep it that way. A file system component will be either a file or a directory, so let's give it a name. We will make it protected because the components will display the information themselves. Now let's create the methods. The display method will get an indent level as a parameter because I want to indent files within a directory when displaying them. We will create the methods for adding and removing file system components, so files and directories. And like that, we have the file system component. The file class. Create a class file that implements the iFile system component interface, or abstract class. The first requirement is the file class should store a file name. The second requirement, the class should implement the display method. And the third requirement, the class should not support adding and removing files or directories. Because remember, it's the leaf, it's the final node. Let's create the class file, which is the leaf, and then implement file system component. The only method we will implement is the display method, because a file can not store files or directories. That's it for the file class. The third task is create the directory class. Create a class directory that implements the iFile system component interface. The first requirement is the class should store a collection of iFile system component objects, so both files and directories. The second requirement is the class should implement methods to add, remove, and display its contents. And the third requirement is the class displays its name and names of the contained files and subdirectories in a structured way. Now we will create the directory class, which is the composite, and we will implement the file system component. The directory can store files and directories, so we will give the private read-only list with file system components. We have to be able to add and remove items from the list, so we will implement the add and remove methods. As last, we will implement the display method. That's it for the directory class. Task 4. Testing the pattern. Write client code to test your composite structure. Requirement 1 is to create several files. Requirement 2 is create directories and add files or other directories inside them. And the third requirement is to display the directory structure using the display method. Let's create several directories and files and then nest them. Now we can display the files using the display method of the root directory. As you can see, the directories and files are shown in a structured way. I hope you learned a lot from this lesson. If you feel like you don't understand the composite pattern as much as you would like, then I suggest playing around with the code or rewatching parts of the video. See you in the next one.